I have a Motorola SLR5700 Repeater that I'm going to be delivering to the Gardena Police Department in their Hardin Repeater facility. And before I deliver the repeater, I want to configure battery backup. The repeater facility has battery backup and a generator that should run for approximately 2 weeks. So all I really need for our digital repeater is maybe 6 hours of runtime. More likely it would just be the power shuts off for a few minutes, and we will just need to be running on battery power for a few minutes. Also, if the repeater room somehow gets damaged or the power goes out or something goes wrong, the communications is one of the most important things that the City of Gardena, the police department, and fire departments will need. They need their communications. So I'm quite confident that the repeater facility will be the first place that they'll come and try to get up and running. So I don't believe that we need any kind of 100 amp hour or 200 amp hour battery. So I'll be going with a LiFePo4, probably a 15 to 30 amp hour battery. It doesn't have to be large, it just has to run for a few hours, and I've already run a repeater for 7 hours on a 15 amp hour battery. So let's do some testing of the repeater charging circuit and the SLR5700. When transmitting, it takes just under 7 amps transmitting off the Bioenno battery. It's a 22 watt output. It's not transmitting and the fan is going, so you're seeing 0.93 amps. When the fan goes out, it sits at about 0.70 amps. Let's just find out. So this is sitting in receive mode with the fan running. The fan has stopped running. The radio is the repeater is at idle, and it's 0.70 amps. The repeater is turned off, it's plugged into the wall. This is a test to see what the amperage is for charging the Bioenno battery. So I'm going to turn it on now. Well, looks like it's charging at 2.99 amps, and the battery is slowly rising. It's set for 13.8. So we're charging at 2.98 amps right now, 13.54 volts, and again it should stop at 13.8. The repeater has been charging for about an hour now, maybe an hour and 15 minutes, and it has settled down to 13.85 volts, and the amperage is 0.00. It does go up to, as you can see, 0.13, but it fluctuated a little bit just to keep the battery maintained, but it is very low amperage. So what this shows is the SL5700 repeater has an intelligent charger. So if you set it to say 13.8 volts, I did that in the software, well, there's a discrepancy, is 0.1385. It could be the meter, but the bottom line is it did charge at a max of about 3 amps, and in the end it has settled down. When it reached the goal that I had put in the software, it's now basically dropped it down to 0.00, 0.10. It's very low, it fluctuates, but it's so this is an intelligent charger that could easily keep a LiFePo4 battery maintained. So this has been a good test of the charging circuit for the Motorola SL5700 Repeater. So it looks like it's ready to deploy. So in conclusion, from the results from this test, I believe you can use a 12 amp hour battery, a 15 amp hour battery, a smallish, LiFePo4 battery, to keep this repeater running safely. The results showed that it the repeater only draws around 7 amps during transmission, especially when, like I said, I'm running the repeater at 22 watts for the DC only. The receive current draw on DC only is like 0.90 when the fan is running, 0.70 when the fan is not running. So what's in listening mode is using very little current. When we do charging of the battery, it does it actually the repeater puts out close to 3 amps, which is really actually just a little bit better for these kind of batteries and size of batteries that I have. So about 3 amps. What it did was it brought it up to 13.8, a little bit higher voltage. Then it went to about 13.85. I don't know if that's the meter is off a little bit, but you know, that's really close to what I want, so it's not going to be a problem. But it did bring it up to the 13.8 or so volts, and then after a while it basically stopped charging. It did just a little maintenance charge of 0.00 to 0.14 volts amps, excuse me. So 0 to 0.14 amps, 1.2 amps, 1.8 amps. It just fluctuated just a little bit, but it was really perfect for maintaining the battery long term. So I think this was a successful test, and I'm going to deploy the system over to the Gardena Police Department very shortly. And so I think this was a good, solid test. Thank you, everybody.